All right, so we're going to get into adding and subtracting fractions. So before we did multiplying and dividing, which you could multiply and divide any kind of radical as long as it has the same or the same index number. Adding and subtracting, it's a little more selective. It's kind of like with your x's. You can add 3x plus 4x, but you can't add 3x squared plus 4x. Those aren't like big terms. So with your radicals, it has to be the same index, and it has to be the same number underneath that radical sign. So for example, those ones are all square roots, so they're all the same index, and they all have the same number underneath, so those could actually be added or subtracted. Whereas my examples here, radical 5 and radical 2 are not the same, radical x and radical 3x not the same, then xy squared and x squared y. So once you've determined that yes, it's the same index, yes, it's the same number underneath, you would actually add or subtract the numbers out in front, and then your radical stays exactly how it is, kind of like your x's do. So if we're adding 3x plus 4x, we simply add the numbers out in front, and then x stays as x. We don't actually do anything to that. That stays the way it is. So same thing happens with our radicals. So let's take a look at our first example here. First off, what number's in front of this radical sign? 1. So 1 radical 2 minus 3 radical 2. Both are radical 2s, so we can actually subtract their numbers. So 1 minus 3 gives us negative 2 radical 2. And then as always, if you can simplify, you would do that at the end. But this one we can't simplify any further. Second one, do we have the same radicals? Yeah. So 7 plus 15 would give us 22 radical x. Radical stays as is. Third one, we've got subtract the cube root of 2 from 5 cube root of 2. So if you remember that phrase, subtract from, means you actually change your order. So it would be 5 cube root of 2 minus the 1 cube root of 2. So 5 minus 1 gives us 4 cube root of 2. Be very careful when you're writing, especially when you have an index that's not 2. So for example, like my 3 here. Make sure it's definitely over that radical sign, because sometimes it can end up looking like an exponent on something if you aren't careful with how you're writing it. So make sure you pay attention to that little detail. So for number 4, what can we actually combine there? The 3 radical 5 and the minus 1 radical 5, because those are the only ones that are like radicals. So 3 minus 1 gives me 2 radical 5. And then the plus 2 radical 3 just kind of tags along at the end, because again, they're not the same, so you can't actually add those ones. So how about for that 5th one? Do we have like radicals? No. But 63 and 28 kind of stick out in my head because I can simplify those. So let's go ahead and simplify that first. What's our perfect square that can go into 63? 9. And the square root of 9 is? So that simplifies into 3 radical 7 once I take out my perfect square. So what's our perfect square that goes into 28? 4. Square root of 4 is? So that turns into 2 radical 7. Now can I subtract them? Yeah. So 3 minus 2 would give us 1 radical 7. So let's try it for number 6. Largest perfect square that goes into 48. 16. Square root of 16 is 4, so that becomes 4 radical 3. 16 times 3 gave us that 48. Largest perfect square that goes into 12. 4, and then I take the square root of 4, so that becomes 2 square root of 3. And then I can't simplify that radical 3, so that just stays as minus radical 3. So then 4 plus 2 minus 1 gives us 5 radical 3. So same process. If they aren't the same, try simplifying. Most of the time they end up being the same after you do that. So the square root of 128. So what is our perfect square that goes into 128? 64. Square root of 64? 8. So that turns into 8 radical 2. Largest perfect square that goes into 32? 16. Square root of 16 is 4. And then what do we do with this 2 and that 4? Multiply. Good. So that becomes minus 8 radical 2. So 8 radical 2 minus 8 radical 2 is 0. So for number 8, still doing square roots. So x squared being under the radical is a perfect square, so that will end up coming out of the radical. Looking at the 8, what's our largest perfect square that goes into the number 8? 4. And the square root of 4 becomes? And the square root of x squared makes that an x out of there, so 2x becomes our coefficient. Underneath that radical, we still have a 2. I'm doing that 4 times 2. Perfect square that goes into 200. 100. Square root of 100 is 10. And again, that x squared comes out as an x. So then 2x plus 10x would be 12x radical 2. All right, you guys go ahead and try those last 4 down there. Practice your simplifying. Simplifying radicals is going to be used a lot. For our last one there, some people get tripped up because that one's a cube root. So you got to think of different perfects. You're not thinking perfect squares this time. You're thinking of perfect cubes this time. So what is our largest perfect cube that could go into 250? 125. Cube root of 125 would be 5. And then y to the third is a cube root. It's a perfect cube because it's 3. You can divide 3 by 3. So we get 5y on the outside. Then we still have the cube root of 2. And again, you got to make sure that little 3 is out there. These are the ones especially we got to be careful. If you're writing too quickly, you can make it look like a y cubed instead of a cube root of 2, which is what it needs to be. Our perfect cube that goes into 16, 8. So that comes out as a 2. And then again, cube root of 2 there also. So then 5y minus 2y gives us 3y, cube root of 2. So you just got to pay attention to that little index number so you know what are you looking at. Square root, cube root, fourth root. All right, switching back to a little bit more multiplying. This time, though, just practicing using radicals with the distributive property. So you're still multiplying, just you're multiplying more than once. So let's take a look at our first example down there. What I like to do sometimes is I like to overemphasize my parentheses because those small ones sometimes just look a little confusing to me. So first thing I always like to do is I like to go and draw those in. So then again, we're going to multiply radical 2 times radical 5. What was our multiplication rule? They don't have to be the same. Nope. And anything under a radical gets multiplied with anything else under a radical, and then stuff not under radicals get multiplied. So that becomes radical 10. 2 times 5 gives us radical 10. And then we distribute it to the 7, so 2 times 7 gives us 14. And then can I reduce a 10 or a 14? No. So that one's done. Let's take a look at our second example there. Radical 3 times 2 radical 12 would give us 2 radical 36. Again, the stuff under the radicals get multiplied by each other. The stuff in front gets multiplied by each other. And then it would be minus radical 15. 3 times 5 gives us 15. So 36 is a perfect square. What's the square root of 36? So then times that 2 makes that a 12. No perfect square goes into our 15, so that's going to stay as radical 15. And this is the form that they always want it to be in. If you have an integer and a radical, the radical always needs to go last. So sometimes you may just need to rearrange it and move it so that it's last, but they always want to see that radical last. Third one, we got to distribute 3 times now. So radical 2 times 5 radical 2 gives us 5 radical 4. And then plus 3 radical 16. Minus 4 radical 64. So square root of 4 turns into a what? 2, and then times the 5 that's up front gives us a 10. Square root of 16 turns into 4, and then times that 3 gives me a 12. Square root of 64 is, and then times the 4 gives us a minus 32. So adding those all together, we end up with negative 10. So then our next one, 3 times the 4 gives us 12 on the outside, and then we get radical 18 underneath. And then minus 9, radical 72. 3 times 24 gives us 72. So our perfect square that comes out of 18 is 9. Square root of 9 is 3, so that becomes 36 radical 2, because it's 9 times 2 to give us 18. Largest perfect square out of 72, 36. Square root of 36 is 6. So times that 9 gives me a 54. Now this one's got one more step because they're both radical 2's, so we can actually subtract those. Gives us negative 18. Negative 18 radical 2 is our final answer. So then these ones on the back, it's more of the same. It's just we have to distribute twice. So 4 times 4 gives us 16. 4 times negative square root of x would be negative 4 square root of x. And then we distribute our positive square root of x. So that gives me positive 4 square root of x. Then radical x times radical x, what does that turn into? Radical x squared, which would just simplify to x. So minus x at the end. And then what happens with our radical x's here? They cancel. So we're left with 16 minus x. So looking at that sixth one, more of the same. 5 times 2 gives me a 10. 5 times 3 radical 3 gives me a minus 15 radical 3. 5 would be times the number out in front because it's not under a radical itself. 2 radical 3 times 2 gives me 4 radical 3. And 2 radical 3 times 3 radical 3 would give us 6 radical 9. Which, what does 6 radical 9 simplify to? 18. Because again, square root of 9 is 3. 3 times 6 gives us that 18. So 10 minus 18 gives us negative 8. Negative 15 radical 3 plus 4 radical 3 gives me a negative 11 radical 3. Again, radical always comes at the end. For your seventh one down there, what do we have to do first? Yep, write it a second time and then do your distributive property. So go ahead and try 7 and 8. Multiply those out, see what you get. For number 7 there, you should have ended up with 69 minus 28 radical 5. Because this 2 radical 5 times 2 radical 5 would have been 4 radical 25. Square root of 25 turned into a 5, so times the 4 is where my 20 came from. And then our last one, 20 radical 3 plus 8 radical 9 plus 5 plus 2 radical 3. 29 plus 22 radical 3. So you should have gotten for that last one.